Logarithms. What is a logarithm? Well, let's think back to sort of simple equation work that you did at GCSE. Suppose, for instance, I've got this here, x divided by 3 equals 4, and I'm asked to solve it. Okay. Well, of course, this is fairly simple for us, isn't it? Because we know here we've got division, x divided by 3, and the answer is 4. And of course, to solve it, the process we use, of course, is we think of taking that 3 over to the side, and we do the opposite, don't we? And we know the opposite is going to be multiplication, because we've got division here. The inverse of division is multiplication. So we take it over and you multiply. You do the inverse operation of division, which is multiply. And you get 12. Now, suppose I've got, for instance, then, say, x squared equals 216. Okay? Well, in this case here, you know the process, don't you? Okay, we're squaring here. So to get rid of that square, I sort of take it over to the side and I do the opposite. Okay, the inverse operation. Of course, we know the opposite is just simply square root. Of course, before I write the square root, I need to write plus or minus. But I'll write square root of 16 there, and of course we know then that's going to be 4. So we've got plus or minus 4, two possible solutions here to that equation. Simple though, isn't it? We know the inverse operations. Well, logarithms help us to solve equations, okay, of this form here, okay. So you can see here I've got 2 to the power x equals 5. Now, this is known, what is called as an exponential function, okay, where we've got this variable x here. And if we were asked to actually solve the power x here, when we've got this function equal to 5, okay, it is possible, but you have to use logarithms, okay. So you weren't taught how to do this at GCSE, it never came up, okay, in terms of solving this type of equation. But ultimately, to solve it, you use a logarithm. And it says here, doesn't it, the inverse of an exponential function is a logarithm. So we need to think carefully about that there, how the process works. And ultimately, when you see this here, so I'll write it down here, you want to work out what x is actually equal to, yeah? So to get x equal to, you've got to think about what we did before with equations, okay? And about getting everything over to the other side, yeah? So in this case here, I need to sort of take that 2 over to the side, don't I? And if I take that over, it's like, well, how do I do that? Because I've got a power here. Well, when you take it over, it's sort of, you want to think about, it creates then a logarithm. Okay, so just like in these cases here, you know, when you had division, well, when you took that over, you knew that you had to multiply. And it's the same here. When you had a square, when you took it over, you knew you had to square root. And it's the same here. When you want the power, okay, you take the 2 over and it creates a logarithm. So what you get is x then will be on its own, the power, and we can actually work out what that power is. It creates a logarithm, so it's literally write down log, right? I'm not going to write the whole word logarithm down, you just write log down. Now that 2, when you take it over, it becomes what we call the base, okay? So every logarithm has got a base, okay? And this is the base here, to my power. So I take that 2 over, so it's log to the base 2 of course, that number then. Okay, so I can quite simply work that out in my calculator. If you notice on your calculator, you have a button up here, okay, that allows you to actually work it out. So log to the base 2, and if I press the arrow across, press 5, I get my answer out to be there. So it's not a very nice number, okay, 2.3. to say 3 significant figures there, okay, but that is the answer. You know, I can always check, can't I, because I can go back here and I can say, okay, well, 2 to that power, so if I put answer, okay, it's come out twice, so if I press 2 to the power answer, it comes out with 5, right? So it does actually work, okay. So we can see other examples here where it would work. I don't have to just show you that one, I could do this one here, for instance. So if we look at this one, now here 2 to the power x equals 8, and you might be looking at this and thinking, well, I actually don't need a calculator here, I could actually work out what that power is going to be, because it actually is going to be a nice number. If you think about it, 2 to the power of something gives you 8, but I can use a logarithm to actually work it out. Okay, so in this case here, the power of course is x, that's what I want. So if you take that over to the side, it creates a logarithm to the base of 2, and I take it over, and then I get, of course, log to the base 2 of 8. So I'm expecting my answer to be 3, of course, on it. Okay, so if I do that, because it was 3, of course I was expected to be 3, because 2 to the power 3 is 8, yeah? Okay, let's do one more. So suppose I've got 3 to the power x equals 81. Okay, so you might spot there what that power x is. That's a nice number again, okay? But because it's a power, okay, I can work it out by using the logarithm idea, okay? Because quite simply, the logarithm function is the inverse of an exponential function, okay? So we've got an exponential function here. I want to work out x. So what I do is I take that 3 over to the side and it creates a logarithm. Now, one way I like to think about it is, because this is my base, I like to think about like swinging the base. That's where I like to think of it as. So there's my base. I swing the base over and it goes nicely underneath there. And so the base swings over, it goes nicely under the log. There's log to the base 3 of 81. And of course, you might know what that is already without checking, but we've got log to the base 3 of 81. Of course, it comes out to be 4. Okay, and you can do that for any power. These are obviously quite nice, but you can choose any one. Let's do one more. So suppose I've got 5 to the power of x equals 212. Well, I don't know what that is. It's not going to be nice, but you can, as I said before, to work out the power x, you can swing the base. Okay, so there's your base. Swing the base creates a logarithm to the base 5 of 12. So we get 1.543 significant figures. And if you want to check, 5 to the power of that answer comes out to be 12, so it works.